All right. 1.8. Intro to variables, algebraic expressions, and equations. So it is very important that you guys write down everything that is on my slides, every word, every phrase, every math, every statement, everything that's on here is meant for you and you only, and for you to use in this course. So the section is 1.8, intro to variables, expressions, and equations. So look at the first definition we have here. Definition is the word is variable. So a variable is an unknown value represented by a letter. So this is an unknown value represented by a letter. Then we have another definition of the word algebraic expression. An algebraic expression is a combination of operations on letters, which is also variables, and numbers. Note, note. A note is pretty much a statement that I'm telling you, I'm explaining to you a concept, or I'm giving you something to avoid confusion. So look at this here. It says, if a number and letter or two letters are next to each other, we can assume they are being multiplied. So for example, 4 times 4x is the same thing as 4 dot x. It's the same thing as 4 parentheses x. These are all the different notations of how we can see multiplication now. And then we have x, y, two variables. So it'll be x times y, which is x dot y. And then we also have x parentheses y. So parentheses and dot. I want everyone to get away from using the old school multiplication. Remember this, 2 times 3? Yeah, we're going to go away with that. We're not going to use this anymore. It's too confusing because it looks like the letter X. So we're going to do 2.3 or 2 parentheses 3, but not the old school multiplication. Okay. Would anyone need more time to copy down this slide before I move on? Unmute yourself and tell me you need more time, or put in the chat. Yeah, so okay. I'm gonna go ahead and give you I'm gonna add 3 minutes to the timer before we move on. Or I'm gonna do 2 minutes, and if we need more than 2 minutes, I'll add an extra time. All right. That was a timer. Is there anyone? I got the comment that someone's already done copying. Is anyone still copying before I move on, guys? I try to be very respectful of everyone. Now, if you're a really slow writer where you don't want to hold up the class and you don't want to always be in the chat, I need more time, I need more. Feel free to take screenshots of the slides with your laptop or take a picture with your telephone or tablet, utilize your technology to take advantage of this, okay? Or if you would like me to email you the slides in advance of class, send me an email. Hey, sir, I would like to present the notes before the lecture. That way you can just have them accessible. I can definitely do that too. Just send me an email, guys. Communications, please. Communication is key. And always advocate for yourself. The worst thing that can happen is I say no or I don't respond, but I'm that's not me, right? I'm just giving you the idea of whenever you're speaking up for yourself, like that fear of rejection or fear of denial, that's you just need to learn to just do it because you're watching out for you at the end of the day. All right, let's move on. Example one. I'll go ahead and give everyone 1 minute to write example one. Example one. So in your notebook, you'll write the word example one or just write example and then write the question, which is evaluate x plus 6 if x is 8 and stop right there. Now, if you're retaking this class and you know what to do already because this is like your second time, then start it. If you're comfortable with starting it, start it. Now, if you have only pen, don't start it with a pen because you can't erase pen. If you have a pencil, that's fine because you can always erase if there's a mistake. So let's look at example one. It says evaluate x plus 6 if x is 8. So they give you, I have 10 seconds left before I jump in, but they give you the expression, right? They give you x plus 6. But now they're giving you a parameter, right? They're telling us, well, what is x plus 6 if x is 8? Well, if x is 8, I'm going to go ahead and replace this x that I have here, and I'm going to put 8 in that place, right? So I'm going to put 8 plus 6. Well, guys, can we do 8 plus 6 in mathematics? Yeah, we can. It was just adding. What's 8 plus 6? 14. Now, if you don't know mental math, then use your calculator. That is one of the resources you are allowed to use in this class. Now, before I have you work on the practice one problem, are there any questions on what we did in example one? Everyone, and now if there's no questions, good luck on practice one. I'll be giving you guys 1 minute to work on it. I'll add more if necessary. So practice one says evaluate x minus 2 if x is 7. Good luck. All right, that was the 1 minute timer. Would anyone like to share what they got for practice one problem? Either type it in the chat or unmute yourself. So Kayla Casper got 5. Does anyone agree or disagree with 5? Thumbs up if you agree, or you can type in agree in the chat.
Agree.
Agree. Everyone, a lot of people are getting 5. Good job. If you got 5, the answer is correct, guys, because you plug in 7 for x, right? 7 minus 2 is 5. And note, make sure you take this time to write this note. I'm explaining to you that when someone says x is something, that's the same thing as x equals 5. So x is 5 is the same thing as x equals 5. That is what my note is trying to say. So please get that note down in your notebook, guys, please. All right. I'm going to go ahead and move on. If anyone needs me to move back to a certain slide because I was going too fast, or you need me to go back, just say something, guys. I'm a math nerd, so whenever I get into teaching math or talking math, I kind of get into it and I get lost. So just whip me back to reality, you know? All right. Example 2. Ah, the plot thickens, class. The expressions get a little more complex. I'm gonna give you 1 minute to set up your example 2 in your notebook. 1 minute, and then I'll go ahead and work it out. Remember, examples, guys. I do. I do. You follow. You ask questions. You observe, and you try to comprehend what I am doing and explaining. Okay, examples. Now, if you're a go-getter and you like to challenge yourself, say, can I do it from what I saw or from whatever? Try it. I'm all about independence, guys. But the moment you know you get stuck, you stop and give me your attention so I can explain the confusion you may have, if you have any. So evaluate 2 parentheses x minus y for x equals 6 and y equals 3. So now they're telling us what x is equal to, right? And then they're telling us what y is equal to. So we're going to use our algebra skills to substitute and simplify. So we get 2 parentheses 6 minus 3. Uh-oh, 2 parentheses 6 minus 3 is a little intense, right? But guess what? Last class we learned what? Order of operations. So do we know how to simplify this? Yes, we do. P in Pemdas is parentheses. 6 take away 3 is 3. Bring that down. Earlier this slide, this lecture, I said a number with parentheses is what operation, class? What are we doing? Multiplication. 2 times 3 is 6, and we are done. Box your final answer. Now practice 2 is on you. Would y'all like 1 minute or 2 minute for practice 2? 1 minute or 2? I'll go ahead and give everyone 2 minutes. Good luck. Write down their problem, guys. Don't just skip things. Write what do you see, because you will see the same type of wording on your online homework, okay? All right, guys. So if you finished up, type your answer in the chat, but don't press enter yet. Have it typed in, ready to press enter when on my cue, okay? We're gonna see everyone's answer at once to see how everyone did, okay? So have it ready in the queue. Three, two, one. Enter. Everyone submit your answer in the chat. How did everyone do? Everyone, we have 20, 20, 20. We have 1, 4, 20, 20, 20. Okay, excellent class. We have 20 and we have a 4. Since we have a disagreement, we're gonna go ahead and show our work of why one answer is correct over the other. Okay, that's called a mathematical debate. So why is it 20? Why is it 4? So look at what we did, guys. Would someone like to unmute and share with us the steps you took since this is a practice problem? What do we do first?
You rewrite out the problem.
Okay, go for it. Good, did that. What's next?
You replace the y with a 4 and then the x with an 8 in the parentheses.
So far, so good?
And then you would simplify the 8 and the 3 since it's first in PEMDAS, which would get you 5. And then you multiply by 4.
Which gives us the
20.
excellent. Thank you, thank you. Good job. So everyone understand why it's 20 now and not 4? George, you good now with why it's 20 and not 4? Okay, good, good, good. All right, let's move on. Example 3. I'll give you about a minute to set up this example into your notes. I forgot my water from the kitchen. I'm gonna go get myself a bottle of water. I'll be back. All right. No worry, Kayla. You're good. We're barely on the 4th slide. And I'm recording the lecture too, so you'll be able to see it.
Okay, thank you so much.
All right, guys, we're example 3. Notice how the expression gets a little bit more complex, right? We have x minus 5y over y for x equals 35 and y equals 5. So first things first, rewrite the problem. X minus 5y over y. Next, we plug in the new numbers we have. Instead of x, I'm going to write 35. Instead of y, I'm going to write 5. So I'm going to get 35 minus 5 parentheses 5 over 5. All I did is plug it in. Because remember what I said earlier, when we have a number next to a letter, they're going to be multiplying. Well, 5, we're plugging in 5 for y, so they're going to still be multiplying, class. And we're doing PEMDAS. And it's a fraction bar, so we do PEMDAS on top. So there's no parentheses, there's no exponents, but we do, so let me write the steps, P, E, M, D, A, S. So we do multiply right here. 5 times 5, class, is 25. Bring down the 5. Now we're done with multiplying. So now we add and subtract from left to right. 35 minus 25 is 10. Then we have 10 over 5, which simplifies to what? 2. And we are done. Does anyone have any questions on the steps we took to get example 3? All right, I'm gonna go ahead and give you guys 2 minutes to work on practice 3. 2 minutes. Good luck. All right, that was the timer, guys. So what did everyone get for practice 3? Go ahead and type it into the chat and press enter now. Everyone got 4. So far, so good. Would anyone like me to work out practice 3?
Can you work it out?
Yes, definitely, definitely. Not at all. I don't mind at all. All right. So we have x equals 6 and y equals 18 for y plus 6 over x. So we'll replace y with 18. So it'll be 18 plus 6 over x, which is 6. Then we do PEMDAS, right? On top, 18 plus 6 is 24 over 6. 24 divided by 6 just simplifies to a 4, and we are done. Ah, Riley, did you see what we get, sir? So did you plug in y for 18? So you forgot that 18 is 18 plus 6 on top, sir, because you know how the expression is y plus 6 on top. You see that? Over x. So x is just a positive 6. So I'm not too sure where you got the negative from. Ah, totally okay. It was an accident. It's okay. Better to understand your mistakes than whatever. All right. Everyone good with practice 3? Let's move on. Here is example 4. Notice how the expressions get a little bit more intense. I'm gonna give you 1 minute to write the example down before I work it out. Now, there's a lot of techniques you can use so this is pretty much evaluating expressions with given variables, right? So what I like to do is I like to always, you can color code it. You can highlight the color that you're going to plug it in and then switch it up for the different letters. So that when you plug it in, you know what it's going to look like. So we know x squared plus z minus 3. We know x is orange, z is yellow. So x squared will be 5 squared plus z, which is 4. Minus 3. Oh, that's an ugly 3. Minus 3. So now we use Pemdas to simplify. Now I'm not always going to write Pemdas, but I want you to know how I do it if I was you. So no parentheses. I see exponents here. 5 squared is 5 times 5, which is 25. Bring down everything else. Then multiply, divide. There's no multiplication or division. So now we add and subtract from left to right. So 25 plus 4 is 29. 29 minus 3 is 26. And we are done. What questions do we have on example 4, guys? Any questions? All right, if there's none, guys, I'm gonna go ahead and give you 2 minutes to do practice 4. Good luck. Thirty seconds left, guys. If you have an answer, type it in the chat, but don't press enter yet. Be ready to press enter on my count, okay? So I have it typed in. Your answer should be a positive number. So if you got something negative, check your math. And it's also a 2-digit number. So if you got a 1-digit number for your answer, double check your work. All right, on count of 3, 1, 2, 3, press enter. Everyone should have got in. We have an array of answers, guys. So we have 18, 18, 20, 16, 20, 18, 18, 16, 18, and 45. So there's a lot of differences. So we have 16. So let's see how it works out, right? Let's work this one out together. Now, practice problems, guys, I don't like to do on my own. Examples, I do by myself. I plug in, I show you how to do the examples. Practice, I will love volunteers to tell me the steps to take. So the first step I'll do is write out the problem again, right? Z cubed plus X. So now who can tell me what's the next step? What will we do next?
The exponent.
So what do we plug in for the exponent, Kayla? What goes for Z?
We plug in 2.
2. So we had 25 minus 2 cube. And then what was for X? X is what? Remember, it's a practice problem. So you guys are telling me what to do. Go ahead.
1.
1. So there you go. And then like Kayla said, we do the exponent first, right? Because of exponents. Can someone tell me what 2 cube is? What is 2 to the power of 3 or third power?
8.
8. So then we get 25 minus 8 plus 1. So that's done for exponents. There's no multiplication division. So now we add and subtract from left to right. Can someone tell me what 25 take away 8 is?
17.
Good. Bring down the plus 1. 17 plus 1 is
18.
18. Thank you. All right. Everyone understand Kayla's steps in reasoning? Everyone feel good with 18 now? Does anyone want to share what was their mistake, how they got 16 or 45 or 20? Anyone want to share their math? That way other students can avoid those mistakes on the assignments. All right, no worries if you don't want to, but just know like people can learn from each other's mistakes, okay?
I know with me, I didn't make a mistake on this, but a lot of times with my math, I don't know if I have like dyslexia or something, but I'll like mistake like a minus for like a plus or like a 2 for maybe like a 3. So like
Uh-huh.
just over like analyzing the problem. Like
Okay. No, yeah. Oh, that's totally understandable for sure, for sure. One thing that I do, because I would make the same mistakes too, Kayla, especially on like quizzes and tests, and I wouldn't get points knocked out. So what I think I did is I would always look at, so you know how I write the steps out? I wrote like here the problem, the steps, and we keep going down. Once I go to the answer, I go back up and I look at everything. I'm like, okay, this looks good, this looks good. And once I know everything is good, then I move on. I'm like, okay, I didn't make a mistake anywhere. But we're human, right? It's part of being a human is we make mistakes. All right. So example 5, guys. This is a word problem, and you will see it on the assignment. So someone say you can't hear me. Hello, hello. Can you hear me? Is my audio better? Hello? Okay. So I'm gonna give you about 2 minutes to write this word problem down into your slide, into your notebook, and then I'll go ahead and work it out. 2 minutes. The expression 5 parentheses f minus 32 over 9 can be used to write degrees Fahrenheit f as degrees Celsius C. Find the value of this expression for f equals 86. So right now, so Kayla, Kaspar, if you want to log out of Zoom and come back in, maybe that should fix your audio. Because everyone else, can y'all hear me? Okay, yeah, other people can hear me. So try that out. Tell me if that works, okay? So the expression is actually is a real life example, guys. So that's the formula you would use to convert F degrees to Celsius degrees. So look at what the question is asking for, right? So the reason why I threw in a word problem here is because I don't want you to be intimidated by them. So we're gonna find the value of this expression for F equals 6. So like we do, we're gonna rewrite the problem again. 5 parentheses F minus 32 over 9. F is 86 now. So we're gonna do 5 parentheses 86 minus 32 over 9. So class, if you're using this, you're gonna use Pemdas first, parentheses first, right? 86 minus 32 is 54. So then we get 5 times 54 over 9. And I'm not like, just because I'm a mathematician doesn't make me a calculator. I don't know what 5 times 54 is. Or actually I lied, it's 270. But I use a calculator to double check my work because I'm not perfect. 54 times 5 is 270. So then I get 270 over 9. Then divide those two at the end. And the answer is 30.
Celsius, right?
30 Celsius. Thank you for the unit correction. So 30 Celsius. All right. Would anyone need an extra minute to copy this slide down before I move on? Speak now or forever hold your truth. All right, let's move on. Now we have a definition here. So I'm gonna give you about 2 minutes to write the definition and the example 6. Definition is a solution. A solution is a value for the variable that makes the equation a true statement. Example 6, determine whether 6 is a solution of the equation 4 parentheses x minus 3 parentheses equals 12. So give you a moment to set that up into your notebook before I jump into it, okay? So make sure you write this definition, you write the example 6, and then we'll jump into it. All right, let's take a look at example 6. So whenever you see a problem that says, tell me whether this number is a solution, is the first thing I want you to think of, I want you to think of this number 6 being plugged in for x. So then we're going to get 4 parentheses 6 minus 3 parentheses equals 12 with a question mark on top of the equal sign. Now, if your instinct was to solve for x to see if it gives you the solution, that's not a bad mentality because that means you know how to solve equations. But think about what the question is asking. Is it asking you to solve the equation? It isn't. It wants you to check, hey, is 6 a solution of this equation? So what do? plug that into the variable, and then notice how I put a question mark on top of the equal sign. That question mark tells you, dude, I don't even know if they're going to be equal. I don't know if 6 works out. So now, do we know how to simplify the left side? Yeah, we do. It's PEMDAS. 6 minus 3 is 3, right? Bring that down with parentheses. 4 times 3 is 12. And then bring down the 12 on every step. Question, class. Now this statement right here, this is a statement, a mathematical statement. Does 12 equal 12? Yes or no, true or false? When you read that statement aloud, 12 equals 12. Is that true to you? Yes, it is. That is a true statement. So therefore, is 6 a solution? It is. So we're going to write 6 is a solution. And then box your sentence. And if they ask you why, to say because when we plugged it in, 12 equals 12 is true. That's why. It gave us a true statement. Are there any questions on example 6, class? Any questions? All right, let's move on. Example 7. I'll give you about a minute to write this down to your notebook before I jump onto it. 1 minute. I'll give you 2 minutes. It's pretty long. Determine which numbers in the set 26, 40, 20 are solutions of the equation 2n minus 30 equals 10. So this example is asking us to do the same thing we just did, but now it wants us to test how many different numbers, class? It wants us to test 3 different ones of them, okay? All right, look at the left column. I plugged in 26, right? Because my job, our goal is to test these 3 bad boys out into the equation to see if any of them are solutions. So I plugged it in for n, right? 2n minus 30 equals 10. 2n minus 30 equals 10. Question mark because we don't know what it is. So now let's simplify this. 2 times 26, y'all, is 52. Minus 30 equals 10. 52 minus 30 is 22. Does 22 equal 10? True or false? False. So is 26 a solution? 26 is not a solution. Now let's look at the middle one. Now we're going to try out 40. 2 parentheses 40 minus 30 equals 10. Question mark. So what do we evaluate first? 2 times 40 is 80. Bring down the 30, bring down everything else. 80 minus 30 is 50. Does 50 equal 10? True or false? False. So 40 is not a solution. Last solution value we're checking, we're testing 20 out. 2 parentheses 20 minus 30 equals 10 question mark. 2 times 20 is 40. Bring down everything else. 40 minus 30 is 10. Bring down equals 10. 10 equals 10 is true. So that tells us that 20 is a solution. And we are done, class. What questions do we have on checking whether numbers are solutions? Does everyone understand the breakdown of what we just did? Okay, good, good, good. Excellent, excellent, guys. All right. Now, this is going to take a good minute. So your job is to write down this chart into your notebook, guys. This is going to be one of your biggest tools this lesson, this chapter. I'm going to give you about 5 minutes for this whole slide to write the chart up. So these words correlate with the operation, okay? So if you see the word sum, it's addition. If you see added to, addition, minus, subtraction, double, multiplication, share equally among, division. Do not skip any of these words, guys. Those phrases are going to be your key to understanding some word problems later on this class. Once you've done writing the chart, make sure you write down example 8, class. Get into example 8. That's why I give you 5 minutes as well to get the chart and example 8 written down. All right, guys, that was a 5-minute timer. I'm gonna go ahead and slowly work on my way to example 8, okay? Look at example 8. It says, write as an algebraic expression, use X to represent a number. So whenever you see the phrase a number, that just represents X, okay? Now our job is to break down these words into actual algebra. So look at example A. I'm gonna write the letter A. 7 increased by a number. 7, right? So 7 is increased by is addition. So it's gonna be plus a number, which is what letter? X. 7 plus X. Now, another way to have written this is you could have wrote X plus 7, because the order of addition does not really matter, right? 2 plus 3 is the same thing as 3 plus 2, correct? So let's look at B. B is 15 decreased by a number. So 15 is being decreased by a number. So what's being subtracted first, the 15 or the X? So 15 decreased by a number. So if I said 15 decreased by 5, what would you write? 15 decreased by 5, what would you write? 15 take away 5, right? But we don't want 5, we want a number, so it'll be 15 minus X. For B, 15 is decreased by a number is 15 minus X. So then we look at C. C is the product of 2 and a number. A number 2 and a number X. Remember, when we have a number next to a letter, they're being multiplied already. So 2X is good enough. Look at D. The quotient of a number and 5. The quotient of a number and 5. So that means it's going to be of a number and 5. So you always put this one on top, a number, and then you put this one on bottom. And E is a tricky one, class. E is the tricky one. I'm going to read it slowly, okay? 2 subtracted from a number. We're taking away 2 from a number. 2, so whenever you see subtracted from, it's flipped over. So it'll be X minus 2, not 2 minus X. Mainly reason why is the keyword here is the from. The from is the keyword here. That changes the order of the words. What questions do we have so far in example 8 class? Any questions at all? Because you are about to apply the same chart. You're going to use the chart and example 8 to do the next set of practice problems. So before you do practice 8, write this helpful hint down so you can see the two differences of these two phrases. So I'm gonna go ahead and give you guys a total of 6 minutes, guys, to write that helpful hint and to work through practice 8, okay? 6 minutes. All right, guys, I'm back in case anyone has any questions. So practice 8 reads, write as an algebraic expression, use x to represent a number. Problem letter A, twice a number. B, 8 increased by a number. C, 10 minus a number. D, 10 subtracted from a number. And E, the quotient of 6 and a number. We have less than 2 minutes before we start working at it as a class. Hopefully everyone's finishing up theirs. All right. So let's look at A, twice a number, guys. Anyone want to volunteer and say what they got for A? Twice a number. What happens when you twice something up? What operation is it and by what number? What is, remember, this is practice, so it's okay if you're wrong. It's about just trying. So I see squared. Someone said, so it is a multiply word. Twice is a multiply, right? And look at the keyword here. It's a number. We're gonna twice a number. We know X is that. When we twice something, guys, what does that mean when you twice something? Times 2. Thank you, Sarah. So it's gonna be 2 times, but it's twice a number. So a number is X, so it'll be 2 times X. So just 2X. Does everyone see why it's 2x instead of x squared? X squared would have been if it was a number squared. Like if it said a number squared, then it'll be x squared. But twice a number means times 2. So 2 times. Yep, Riley. Yep, Jacob. Yep, Tanya. We're going to multiply. We're multiplying 2 and x with each other. Okay. Let's look at B. So if you got 2x, give yourself a little check mark. Let's look at B. 8 increased by a number, class. Anyone want to share what they got for B? 8 increased by a number? Either type it in the chat or unmute yourself and let the class know. I have an 8 plus x. Anyone agree or disagree with 8 plus x?
I agree.
Excellent, excellent. So far, so good. Anyone want to share what they got for C? C says 10 minus a number. Remember, we're converting words into algebra. What's 10 minus a number? Remember, it's a practice problem, so you guys have to say it. So I see 10 minus x. Excellent, guys. Excellent, excellent. So if you said 10 minus x, you are correct. Now, let's see how you guys do with D. What about D? 10 subtracted from a number. What are your thoughts on D? Is it exactly the same thing as C? X minus 10. X. So if you got X minus 10 for D, you are correct. The key word there is from, subtracted from. And then E, the quotient of a 6 and a number. So what's going to be the choice for E, guys? What over what? What's on top and what's on the bottom? Six over X. That's correct. So if you got 6 over X, you are on the right track, guys. Good job. Now, are there any questions on the steps we just did right now, guys? Any questions on any of the steps? All right, we're moving on. We're right here in 2.5 now. All right, I'm gonna go ahead. Now, before we jump into 2.5, let's go ahead and take a 5-minute breather. Okay, guys, let's stretch our legs, give our hands a little break. I'm gonna pause recording. So we're gonna go ahead and cover 2.5 order of operations class. The reason why we're gonna go ahead and bring back these order of operations is we're now gonna deal with integers. We're gonna deal with positive numbers and negative numbers. So the steps are there for us to use. So PEMDAS, you have them there. Look at example 1. Find the value of each expression. Now, pretty much what number 1 and 2 is basically there to show is what happens when we have parentheses around the negative number. So -3 squared is pretty much saying -3 times another -3. Now, before we jump into the math of this, the one thing I want to explain to everyone is a positive times a positive is always going to be a positive number. A positive times a negative will always be negative. The same thing with the vice versa. And two negatives make a positive. So this little chart is as a reference of multiplying positive and negative numbers. Now, if you notice the key difference here is you see that when you pretty much have one positive, one negative, it gives you negative answer, like a negative number. And when they're both the same, it gives you positive. So a -3 times a -3, guys. Two negatives make a positive. 3 times 3 is 9, and we're done with the first one. The number 2 is -3 squared. So what they want us to do is they want us to do negative parentheses 3 times 3. They want us to square first and then multiply the negative with it. Well, 3 times 3 is +9 times the negative is -9, and we're done. And number 3, 2 times 5 squared. That's pretty much wanting us to do 2 times 5 times 5. Well, 5 times 2 is 10, times 5 is 50, and we are done. What questions do we have on 2.5, if any?
Can you go over number 2 again?
No, yeah, not at all. So if you look at number 1, right, the parentheses is around on the outside of the print of the negative, right? Here in number 2, we have no parentheses. So what they want us to do is they want us to take the negative of what? What's after the negative sign? 3 squared. Well, we know 3 squared is, right? 3 squared is just what? 3 times what? 3. And what's in the front of it? What's still there that we cannot neglect? The negative sign, which is why I wrote it out like this. So negative times 3 times 3. Well, 3 times 3 is 9 times a negative makes it a negative 9. Did the highlighting colors work for you better, Sarah? Seeing the where we get to the steps?
Thank you.
Mhm. Any other questions before we move on? All right, now here is this helpful hint, guys. It does say a lot of information, so I am gonna give you guys about um so I'm getting the question is, this might be funny, but why is it not 25 times 25? Well, because it's not a 25, sir. Let me make this bigger. Is a 2 times 5 squared. You see that, sir? I know on the computer screen it's much harder to see, but I just enlarged it a little bit. So do you see the dot between the 2 and the 5? Therefore making it not 25, but 2 times 5 squared. Anytime, sir. No, that was a great question. Yes, Nicholas.
Okay, so for number 2, I got confused. So when do you know like how to use the parentheses if it doesn't show them?
Great question. So that's exactly the point. When you see the parentheses is when you do the negative times a negative, because the negative 3 is what's being squared. The parentheses will be there to tell you, hey, Nick, we're going to go ahead and square this negative number. Whereas number 2, hey, this 3 squares being is going to be negative at the end, but there's no parentheses. So it's when you see the parentheses is when you apply the step 1, is when you see parentheses. And when you don't see parentheses is when you apply the logic behind number 2.
Oh, okay.
So you
I got
pretty
it.
much, yeah, does that make sense?
Yeah.
Okay, cool. Great questions, guys. Now you write this helpful hint so you can see the differences between with parentheses and without parentheses. Okay, I'm gonna give you all 4 minutes on this helpful hint. 4 minutes. Good luck. All right, guys, that was a timer for this helpful hint. Does anyone need more time on this slide before I move on? All right, moving on. Here is the first set of practice problems, guys. We're gonna apply the same things we just did in example 1, 2, and 3. Okay, I'm gonna give you guys about 2 minutes to write it up and set it up and work them out. This goes back to your question, Nicholas, like how do we know which one to do? Well, just look at what the problem shows. Does it have the parentheses? Does it not? That's how you know which logic to apply. So good luck, y'all, and then we'll talk about it in just a moment. All right, guys. So we're looking at number 1. Anyone want to share what they got for number 1? Their final answer?
Positive 16.
Positive 16. Anyone agree or disagree with 16? You can either type in the chat, you agree, or unmute yourself and say agree. Okay, excellent, excellent, Priscilla. She agrees. Anyone else? Did other people say got a different answer since no one's agreeing? Okay, there you go. Okay. If you got a positive 16 for number 1, you are correct. Would anyone like me to work out number 1? Yes, I can. So we have -2 to the 4th power, guys. So what is, remember, do we know exponents? Yeah, exponent is repeated multiplication, right? So what's being repeated right here? The -2 is the base. So -2 is going to be repeated how many times? 4 times. So I'm going to write -2 times -2 times -2 times -2, a total of 4 times, because that's what a power does, right? That's what an exponent means, repeated multiplication. Everyone with me? And now we just multiply from left to right. -2 times -2, that's a positive 4. Bring down everything else that we didn't do yet. A 4 times a -2 is a -8. Bring down the -2. -8 times -2, 2 negatives make a positive. 16, and we're done. What about number 2, class? Anyone want to share what they got for number 2? Ah, got a lot of -16s. -16, guys, is correct. Yes, I can. I'm gonna go ahead and work out the -2 to the 4 real quick. So I'm gonna do that in blue. So number 2, -2 to the 4. So here, since there's no exponents, I mean no parentheses, what number is being exponented by 4? What number? Just the 2, right? Not negative, just the 2, right? So then that means we're gonna have equals. So we get equals negative parentheses 2 times 2 times 2 times 2. The 2 is being repeated by 4 times. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. But what's outside of the parentheses? The negative is still there. Therefore, it's -16. So the difference from these two is remember the symbol. Number 1, what was around the -2? Parentheses. Number 2 did not have any parentheses, which is pretty much what this helpful hint explains. So were you able to get down this helpful hint, Kayla? So you see here it says -3 squared and -3 squared do not mean the same thing. No need, no, you're good. I was just making sure that you have it. And there you go. If you look at Daryl's comment, remember order of operation, exponents is next if there's no parentheses. So this highlights the difference, okay? So hopefully that makes you feel a little better. Now, number 3, guys, would anyone like to share number 3? What they got for number 3? Let me take a look. I've got a couple 108s. We have actually a handful of them. 108. If you got 108 class, you are correct. Good job. Would anyone care for me to work out number 3 before we move on? All right, let's take a look at number 3 real quick. So number 3 says, let me write it over here. 3 is 3 times 6 squared. Well, that's just 3 times 6 times 6, right? Because Pemdas, 6 times 6. Well, 6 times 6 is 36. So we have 3 times 36. Then we do 3 times 36 in our calculator, which gives us 108. Remember to follow Pemdas, class. All right. I'm gonna go ahead and give you guys a couple minutes to write down this example. Give me 1 second. Give you 2 minutes to get started. So these are just expressions like we did earlier, but now there's negative numbers involved, negative and positive. All right, let's take a look at A real quick, okay? A is simplify the expression using PEMDAS, right? Now, P for parentheses, typically it means when there's like a parentheses with things inside of it, like adding, subtracting, whatever. If this right here, this parentheses is to denote multiplication. We're gonna be multiplying these two. Remember I showed you earlier on how the different multiplication looks like? Well, this is multiplying. So we're good with parentheses. There's no exponents, so we're gonna multiply first. -6 times 2. -6 times 2 is -12. And I'm gonna bring down the -3. Now that I did the top and the bottom is by itself, now we're gonna divide the top by the bottom. -12 divided by a -3. Well, remember, two negatives make a positive. 12 divided by 3 is a +4. And we're done with A. Now let's take a look at B. B is still a fraction, right? We have a top and a bottom. So we're going to simplify the top first to one number and then the bottom by a number and then simplify by dividing the top and the bottom. So the top just says 12 take away 16. So the way I like to use addition and subtraction class, I like to use the idea of money and bank accounts because all of us are adults. All of us have handled money at some point. Now it's better to improve the skill set, right? Of being comfortable with numbers back and forth. So let's look at B, 12 take away 16. 12 means you have $12 in your bank account. -16 means you spent 16 at the store because of what you needed to buy. Well, we didn't have enough to cover it. So what's our balance to the bank? What do we owe? A negative what? 12 take away 16. Now you can always plug that into your calculator to help you out too.
-4.
-4 over, look at the bottom of the fraction, -1 plus 3. -1, if you saw a -1 on your bank account, you owe the bank $1, right? Because you're negative. But plus 3 means you put $3 in your account. So if you owe the bank 1 and you gave them 3, how many do you have left for you? You have 2.
2.
So now we're just going to divide -4 divided by 2, which gives us a -2, and we're done. Use a calculator if the adding, subtracting, dividing is messing you up. Let's look at C. We're doing PEMDAS first, right? There's no parentheses to simplify, but there is an exponent right here. We're doing this E, -2 to the third power. Well, -2 to the third power is just pretty much going to be -2 times a -2 times another -2. It's going to be 3 of them. So what does that simplify to? Well, help me out, class. -2 times -2, two negatives make a +4. Can someone tell me what a +4 times a -2 is going to be? 4 times -2? -8, correct. So then we bring down the -8. And I'm going to go ahead and bring down everything else. I'm going to bring down the plus 30 plus 60. Do me a favor, guys. Whenever you see a plus, a negative, like you're adding a negative, guys, what's the same thing as adding a negative?
Subtracting.
As subtracting. So we're gonna rewrite this as subtracting. So we're gonna get 60 plus 30 minus 8 because they mean the same thing, okay? So now let's go ahead and add and subtract from left to right. 60 plus 30 is 90. Minus 8 is 82. And we're done. with C. Now it's very, very important that you guys remember this. Adding a negative is the same thing as subtracting, okay? Let's look at D. D, there's no parentheses to simplify, but we have exponents. We have 3 different exponents we have to simplify in D. So let's do the first exponent first, -4 squared. Is there parentheses? Yes or no?
No.
Nope. So we're going to write it as -4 times 4. 4 times 4 is just 16. So what kind of 16 should it be, class? Negative. Now look at the second one. Plus -3 squared. So how am I going to simplify that? Am I going to use parentheses or no parentheses?
Hey, sir, is that -4 times -4?
No, ma'am. It's only one -4 with the +4.
Okay.
The only time we include multiple negatives if what is around the negative number. What's the key symbol that we need to be on the lookout for? Anyone?
Parentheses.
That's correct. So notice how -2 cube had parentheses. That's why I wrote it 3 times with parentheses. Here, -3 does have parentheses twice. So can someone tell me what a -3 times a -3 is?
+9.
+9,
I had a
correct.
question because
Go for it.
on C,
Yeah.
it was -2 in parentheses with exponent of 3. So shouldn't that have been a +8?
It would have been positive if let's look at the math again. So it's -2 3 times, right? -2, -2, -2. Well,
Mhm.
we know how many negatives does it take to become a positive though?
2 of them.
2, right? So the -2 and the -2 makes a +4. You see the +4 right there? But we still have how many more negatives though?
One
One.
more.
So then we have a +4 times a -2. So a +4, -2, and remember the symbols I told you? A positive negative makes a -8. So the parentheses doesn't imply that it's going to come out positive. It just means you're going to multiply the negative number by it to itself multiple times. Here, 2 negatives make a positive for the D for -3 squared. That does gives us a +9 because we got only 2 negatives to mess with. Whenever it's an even number, it's gonna come out positive. But notice 3 is what kind of number? 3 is odd, right? So it's not gonna have that extra negative to cancel out the negative. Does that make sense?
Yeah.
Okay, great
Thank
question.
you.
No, thank you for your question. That was an excellent question. All right, so let's look at, we're not done with D, right? We still have to mess with 1 cube. I brought down the minus sign, right? Because it's not in parentheses. Now I just got to evaluate 1 cube. 1 cube is 1 times 1 times 1. So can someone tell me what 1 times 1 times 1 is?
3.
Think again. 1.
Iron 1.
There you go. There you go. There you go. As long as you caught yourself right. And now we have this now. So let's see how that simplifies. So we have -16 plus 9 minus 1. There's no more exponents. There's no multiplication or division. So now we're going to add and subtract from left to right. Class, -16. Do you have 16 or do you owe the bank 16 if you have -16?
Oh.
You owe. Plus 9. Are you putting in money in your account or are you spending?
Adding.
You're adding money to your account. So if you owe them 16, but you pay off 9, because that's what you got in allowance, what do you owe the bank now?
-7.
-7, good. So these two combined give you -7. bring down the -1. So we now owe them $7, but we got tempted. We bought a bag of hot Cheetos for $1. So now what do we owe the bank? What's our final answer? The answer should be -8. Excellent, guys. Did everyone see how I broke down the exponents with parentheses, without parentheses? Does everyone follow with me?
Yes.
Okay, good, good, good. Now here's your first four practice problems, guys. A, B, C, and D. I'm gonna go ahead and give you all 5 minutes to work on these. Good luck. I'll be here. I'm just drink some water. All right, make sure you're following the same logic we went over in the lecture, guys, because if you notice, these examples kind of emulate the same energy that that you saw in the example. So try to follow with it, okay? Now, if you get stuck on the logic, that's when you ask me or Daryl for help, and we'd be glad to help you out, guys.
I do have a question about D.
Go
For
for
the
it.
2 with the exponent of 3, the product of that's gonna come out to a negative number, correct? Because it's not
Yes,
parentheses. Okay.
that is correct. That is correct. Great question. Great question.
And if we're dividing a negative and a negative, it's gonna be a positive number.
That's correct. That is correct, Sarah.
Okay, thanks.
And then for those of you that don't remember that, make a little note. A number, negative number divided by negative is always positive. That way you can see it. I'll write it over here to the side so y'all can see it.
And the same thing for multiplication, right?
Same thing with multiplication. That is correct. When dividing or multiplying a negative with a negative will result to a positive. And I'm sorry for my terrible handwriting, guys. I'm a lefty. I know I just took a shot at lefties. Come at me. Just kidding. Don't come at me. Peace and love. Peace and love. But hopefully that note helps out some of you guys. All right, that was the timer. Would anyone like more time to work on these examples? Or are y'all ready to discuss them? All right, let's look at it. So got number A, guys. Number A. Letter A. Letter A. Anyone want to share what they got for A, guys? Their final answer? Everyone's pressing. Okay. 5. Does anyone agree or disagree with 5? Everyone, okay. So far, so good. Excellent. Everyone got 5, so that is correct. Is there any students that would like me to work out A? Yes, I could definitely work on it. So the 25 on top is by itself, so there's nothing to mess with, right? So I'm gonna rewrite it alone. But the bottom of the fraction, we have 5 times -1. Excuse me. 5 times -1 is -5. Now we have no more expressions, no more operations. Now we're going to end it by dividing the top and the bottom. -25 divided by -5, which is where our note comes into play. 2 negatives make a positive. 25 divided by 5 is a +5. Now, what I do when I see 2 negatives on top of each other, class, I'm going to show you what I do. Not that you have to do it. I like to make them into a plus by drawing a line through both of them, seeing how you see how they both look from a negative to now both of them are positive signs now. You see that? That is a trick that I learned as a young student, but that was years ago. I still do it to this day. Do you have to do that technique? No, you do not. As long as you remember 2 negatives make a positive, and then always check your work with a calculator. All right. Anyone would like to share their answer for B? On the count of 3, everyone put it on the chat for B. 3, 2, 1. Enter. What'd y'all get for 3? Excellent. Excellent. Excellent, guys. I see 3s and I see 1, 6. So let's check it out. All right. Let's see how we did. All right. So on the top part of the fraction class, on the top, -18 plus 6. What does that simplify to? You owe the bank 18 and you deposited $6. That's a -12. Thank you, Marina. Now look at the bottom of the fraction, -3 minus 1. So -3, we owe the bank 3, but we spend an extra $1 because we just couldn't help ourselves. The paletero man was outside. So -3 minus 1, what is this, the bottom simplified to, class? What's -3 take away 1? That is -4, right? So now we're dividing, right? Two negatives, -12 divided by -4. How many 4s go into 12? 4, 8, 12. So the answer is a +3. Great job, guys, on B. Ah, good, Sarah. You see how Sarah put how she found her mistake? That is the goal of these practice problems. The goal of the reason why I have them in my lessons is so that you can apply what I just showed you to go ahead and work out any little mistakes that you may make during class. You can just share with us like, hey, I didn't get that. Oh, hey, sir, I don't know why you got that. Hey, this, hey, that, hey, that. That's what I love about this kind of interactive lecture, is that you kind of get to experience it yourself. That's the best way to do math, is by you doing it yourself. All right, let's look at C. Are there any answers that anyone want to share for C? Anyone want to share what they got? 16, 16, 16. Okay. 16 again. Interesting. Would anyone like me to work out 16? Okay, let's look at C. So we have agreed. Good. So far, so good, guys. You are doing really well for everyone to be on the same page. Okay, let's look at C. So before we can add, we have to do exponents first, right? So we're gonna have a -4 times a -4 times another -4. A total of 3 -4s, right? So -4 times -4 is a +16. But we still have one more -4 to worry about. Can someone tell me what 16 times -4 equals to? A six
-64.
-64. But class, we have an adding, a subtracting. We're adding a negative number, which is the same thing as what? Same thing as subtracting. So now we add and subtract from left to right. 30 plus 50 is 80. Bring down the 64. Those two simplify, give us 16, and we are done. So if you got 16, good job, class. Good job, good job. Now, what about D, class? Are there anyone want to show what they got for D? I see Jacob got a 3. Anyone else? We got -23 from Maya. We got a 9 from George. 9 from Priscilla. 9 from Tanya. So we have so far 3 different answers. But the 9 tends to be the most frequent one. Now, doesn't necessarily mean it's right? Let's go ahead and see what it is, right? Let's figure it out ourselves. So for D, for -2 cubed, how would that be expanded, guys? Would it be 3 -2s in parentheses, or just 1 negative with 3 2s? How would you write the first exponent out?
1 negative 3 2s.
There you go, correct. And then let's simplify that. -2 times 2 is what? -4. -4 times 2 simplifies to a what, class?
-8.
That is correct. Now let's look at the second exponent. So it's plus. Now what's going to be, how is that going to be expanded, guys?
2 -4s.
2 -4s. That is correct. So look at the 2 4s. -4 times -4. 2 negatives make a what?
Positive.
Positive 16. Good, good, good. Now we have a one last plus. We have plus, right? How many ones?
5.
But all of those multiply give us what?
1.
Correct. So now we add and subtract from left to right. -8 plus 16 is 8. Bring down the plus 1, which is 9. And we are done. What questions do we have seeing these practice problems now, guys? Any questions at all?
I have a question.
Go for it.
On number C, when the step where it says 30 plus 50 and then the plus -64, why did it change to -64? Because I added it and I got 144 as my answer.
Ah, but remember, so when you do 16 times a -4, a positive 16 with the -4, it gives you a what? A -64, right? And but remember the original operation was a plus, right? Up here. So this plus is for this plus right here. But think about it this way. If I asked you to add a negative number to your money, and you're adding something negative, is that going to add to your wealth or take away from your money overall? If I tell you, hey, I want you to add -$20 into your account. Well, if I told you to add positive 20, you get $20 richer, right?
Yes.
But if I tell you to add -$20, what really, in reality, what's really happening?
It's the same as like not adding it.
You're not adding it. The opposite of adding is what?
Minus.
Minusing. So that's why I rewrote it again. I highlighted the plus and negative to show you that those two combined make it into actual a minus sign, actually overall in reality.
Okay. Thank you.
No, that was a great question. All right. Any other questions before we move on? All right, let's keep going. We have three more problems, three more example problems, E, F, and G. I'm gonna go ahead and give you guys 2 minutes to set them up into your notebook before I begin E, okay? 2 minutes before I jump into E. It's the same logic, but they look a little nastier, right? But do not be intimidated by how ugly they look. It's all about confidence. It's about looking at what you see and breaking it down to make sense, okay? I'm writing the Pemdas steps to the side here because we are going to have to utilize these steps shortly. All right, let's take a look at E, all right? That was a timer for me to get started. E, We have this expression, right? We have parentheses, but if you take a look at number here, we have plus a -2, which is the same logic we're gonna apply right now. So let's first go ahead and do P first. Let's do the parentheses, right? Which is 4 take away 7. Can someone tell me what 4 take away 7 is? You have $4 in your account. You spent 7 at the store. Your balance to the bank is -3. That's correct. So then we get 3 parentheses -3 plus parentheses -2 minus 5. But guys, remember what I said about plus and negative? What can I simplify that to? We're going to do all of them together, Sarah. These 3 are examples that I'm going to work with you. The next slide is going to be you doing the practice problems. So we have plus and negative. Remember, adding a negative is the same thing as what? Subtracting. Thank you, Fatima Gul. I hope I said that name right. You can correct me in a bit when I do roll call. So the plus and -2 is a minus, right? So I'm going to replace the parentheses because we know we're just subtracting 2 pretty much. Everyone see that, right? That plus and negative just makes it a minus overall. So now we're going to go ahead and follow Pemdas. So we did parentheses, check. No exponents, check. Multiply, divide from left to right. 3 times -3. 3 times -3 is -9. Bring down everything else. So we're done with multiplication and division. Now we add and subtract from left to right. -9. You owe the bank 9, but you spent $2. And then you spend $5 more because we just don't know how to spend money. So how much do we owe the bank now? If we owe them 9 and we spend 2, that's 11. 11 spend, well, that's from the first 2, correct. These 2 give us -11. Bring down the -5, and those 2 give us what? Final answer will be -16, and we're done. What questions do we have on any steps that I took just now? Any questions at all?
I had a question. Was it -2 or -2?
So are you talking about like right here, the yellow highlighted part, that part?
No, where it says -9 and it says, is that a negative or a minus?
It's a minus. It's a
Okay.
minus.
Okay, thank you.
Whenever you notice how I started with a plus, a -2. When we absorb these 2 together, when we combine adding a negative is the same thing as subtracting 2. So whenever the highlighting went away, that's when we shifted it from a negative to a minus, okay? Let's look at F. F has parentheses -3, absolute value of -5 minus -2 plus 4 squared. If you look at absolute value of -5, the absolute value of any number, it's always going to come out positive. So let's go ahead and do absolute value first. So I'm going to rewrite this. So it'll be -3 times a +5. Now look over here. We have a negative and a negative, minusing a negative. So we know adding a negative is subtracting. What about when we subtract a negative number? When we subtract a negative, remember 2 negatives make a what? A positive. So what you're gonna do is, you see how we have minus parentheses negative? I'm gonna make a plus sign using the 2 negative signs. So this is actually +2 plus 4 squared. I'm gonna erase that so you can see it, okay? This, I'm gonna use orange. This gives us this. So we did the absolute value. Everything that's inside the absolute value is positive. 2 negatives make a plus. Brought down everything else. Exponents, 4 squared. Can someone tell me what 4 squared is? 4 times 4 is, I believe it's 16. Now I'm going to bring down everything else. So we're done with the exponents. Now we're going to multiply. -3 times a +5 is a -15. Now I'm going to bring down everything else. -15 plus 2. I owe my bank $15, but gave them 2. So I only owe them -13. And then -15 plus 2 is -13. -13 plus 16. So we owe the bank 13, but we give them 16. So now we just have 3 for ourselves. Now, if you want to do it one step at a time, which you're encouraged to do, these two give us -13, bring down the plus 16. These two give me the +3. But since we're not in our first lecture, I'm gonna simplify things a little smoother if you can, but no need to skip steps if you cannot. All right, we're on G. -2 bracket -3 plus 2 parentheses -1 plus 6 parentheses bracket -5. If you're doing PEMDAS, which parentheses will we do first? The parentheses or the bracket, class? The inside or the outside?
The parentheses.
The parentheses. We're gonna mess with this one first. -1 plus 6. You owe the bank $1, but you give them 6. So now you have $5. I'm gonna bring everything else down. Now our job is to simplify the brackets now. Our job is to simplify the brackets, this part here. Now that's what we need to do now. So let's do it. How do we do that, right? So to do that, 2 times 5 is 10. Bring down everything else. -3 plus 10. -3 plus 10. I believe that is, we owe the bank 3, 7, right?
+7.
Sorry, I had a mental fart. And then now we're done with the brackets, and now we're gonna multiply these two. -2 times 7 is -14. Bring down the 5. You owe the bank 14, but spend 5 more, so you owe them 19 in total. And we are done.
I just need a minute to copy it down.
Yeah, let me know when you're good. And then you're gonna get practice problems that are similar to these, guys. They look complicated, but I want you to follow the recipe that I did as on the notes. And then we'll work them out together if necessary. Excuse me.
Okay, I'm done.
All right. Thank you for letting me know. All right. Here's your practice problem. I'm gonna give you all 6 minutes, two for each one, and feel free to ask questions as we move along.
Testing. Professor, can you hear me?
Yes. Yes. What's up?
Oh, the power just went out on campus, at least in my building. I don't know
Oh.
if it's going to affect the internet. So if I disappear, it's probably because the power to the router went down. But so far, I still seem to be on.
Okay. Thank you for letting me know.
Oh, so Sarah must be on campus as well. She's saying the same thing. But so far, it seems to be okay. But just so you know,
Thank you for the heads up.
welcome.
All right, guys. So let's talk about the first one. So this is gonna be we'll call this 1, 2, and 3. Anyone want to share what they got for number 1?
I got 22.
We got 22. We got -19. We got 23. We have different answers. 27, -27. Let's follow the PEMDAS, okay? So let's do PEMDAS. Okay, what will we do first, right? Parentheses, right? What happens in the parentheses 2 take away 9? What happens with 2 take away 9? What does that simplify to?
-7.
-7. So then we get 2 parentheses -7, bring down the plus -12 minus 3. Then we use the same logic here. What's the same thing as plus negative? Subtract. So then we get 2 parentheses -7 minus 12 minus 3. Now we're done with parentheses. There's no exponents. Now we're gonna multiply, divide from left to right. 2 times -7 is what, class? Was 2 times -7?
-14.
-14, that's correct. So then we get -14 minus 12 minus 3. Now we add and subtract from left to right. So -14, do we have 14 in the bank or do we owe 14? Do we have or do we owe?
Oh,
We owe. Minus 12, did we spend 12 more or did we put 12 in our account?
spend 12.
Spent
We
12 more.
spent 12. So if we owe 14 and we spend 12, we now owe them how much? Well, to add them up, right? Because we spent them back to back. So it'll be what? Negative what? What do we owe the bank now after these two?
26.
Negative 26. But we spent another $3, which makes it into a what?
-29.
And yep, and we're done. Does everyone see their mistakes of that didn't get to -29? There you go. You multiply it. There you go. So fix those mistakes, okay? Make those corrections now.
I was realizing like on a couple of them where I was going wrong because like with the negative numbers in parentheses, like I didn't know what to multiply them against, and then I realized
Ah,
the negative sign.
No, that's a good point. I did not think about that, Kayla. Because yeah, we're used to seeing parentheses for multiplication sometimes. That when we see our brain right away goes off of that. So no, you're good. But now you see how you see how I got rid of them in the purple? That's because it threw me off too. So I got rid of them in my own head. So that way I don't make that same mistake. So little techniques that we're learning here and there. Okay. Let's look at 2. Anyone want to share what they got for 2?
I got negative 35.
Negative 35. Let's see how everyone else did. We have negative 35. Negative 35 from Riley, from Tanya. So far, it seems to be the consensus. Anyone else got something different, guys? Oh, we have a 45. We have a positive 45. Interesting, interesting. All right, let's go ahead and let's go ahead and work this one out together. So the first things we want to look at that. Oh, Jacob got 429. All right, all right, all right. Let's go ahead and see what happens, right? Let's go ahead and work this one out ourselves, okay? So we know absolute value becomes what? A -8. The absolute value of -8 becomes what kind of 8?
+8.
+8. I'm gonna bring down everything else. Plus -3 plus 2 cubed. Okay. So see, you already caught your mistake. You caught your mistake so far. So it's a positive, it's absolute value, not a 1. Absolute value. All right. So let's keep going, right? Let's keep going. So we simplify that. Now what happens to this plus and negative? That's the same thing as what? Subtracting, right? So let's go ahead and bring it down. Notice how these little steps kind of make it look a little nicer from what we started with, right? So now we do PEMDAS. No parentheses to simplify. Exponent 2 to the power to the third power. Can someone tell me what 2 cube is? Anyone work that one out? 2 cube, what'd you get? We got 8 from Tanya. That's correct. Bring down everything else. So after exponents, we're gonna multiply and divide from left to right. Where are we gonna multiply? -5 times 8 gives us what, class? -5 times 8. What does that give us? -40. Bring air down everything else. And now we're gonna go ahead and add and subtract from left to right. -40, guys. Do you have 40 in your account? Or did you spend 40?
Spend 40.
We spent 40. -3, we spend an extra $3. So now we owe the bank 43. But we're gonna go ahead and put $8 because we're trying to get rid of our negative balance. If you owe the bank 43 and you deposited $8, what do you have left? What do you still owe? -35. There you go. Good job if you got -35. All right. Any questions on number 2 on any of the steps? All right. What did people get for C? I mean, for number 3. Anyone want to share what they got?
I got -10.
-10. Anyone else? Let's see what we got in the chat. We have -10. And then we have -23 a couple times. Interesting. See, for me, I love it when we get different answers because it allows me to work it out with you and everyone gets on the same page as we fix this, okay? So if we're doing PEMDAS, guys, for P for parentheses, are we gonna do the bracket first or the parentheses inside?
Parentheses.
So if we do the parentheses class, -3 plus 5. If you owe the bank 3, but you give them $5, you have how much to your name?
2.
2. So I'm going to bring down everything else. So now our job now is to simplify the brackets. So till we get one number to multiply with the -4. So in the bracket, am I going to multiply 5 times 2 first, or am I going to do -6 plus 1 first? -6 plus 5 or 5 times 2? What's first, adding or multiplying? Look at the pen.
Multiplying.
Multiplying. Yeah, 5 times 2 is what, class? 10, right? So bring down the 10, bring down -6, and bring down everything else. -6 plus 10. So you owe the bank 6, but you gave them a $10 bill to add into your account. What do you have your what's left over? What do you have to spend? Or do you still owe?
You have a +4.
You have a +4, right? Because you owe them 6, but you gave them $10 because you made a good tip from work, your server. So now we have -4 times 4, class. What's -4 times 4? -16. Bring down the -7. -16 minus 7 is -23. And we are done. Does everyone see how the third one is broken down? What questions do we have about these practice problems? Any questions at all?
Yeah, I know I got 35 for the first one, but like I forgot why I changed the 8 to a positive. Like what's the rule behind that?
Which
On number 2, I'm sorry.
Oh, right here, the number 2. Oh, because the absolute value. Thank you for reminding me. Let's make a little note about absolute value. So note, when taking the absolute value of any number, it will always be positive. And I'm going to give 2 examples of absolute value. So the absolute value is those vertical lines where Jacob thought it was a 1. So make sure they're vertical, by the way. So absolute value of 7, see how the vertical lines is equal to +7. The absolute value of -9 is equal to +9. These are 2 different examples of absolute value, but they always come out positive, okay? Does that note make sense, Kayla?
Yeah, but
That's
yeah.
why that -8 became +8, ma'am.
Okay.
In that example, because it had absolute values. That was a great question. All right. Go ahead and make this one real quick. No, 280. Oh, nope. I don't know how to work this. All right, can you guys see that slide, guys?
Yep.
Yes.
Okay. All right, I'm gonna give you about 2 minutes to set up the, 3 minutes to set up this example. It's evaluating algebraic expressions. So it's the same thing we've done before. We're plugging in the numbers into letters, but now the numbers are gonna potentially be negative as well. I'm gonna give you time to set this up before I jump into it. All right. All right, let's take a look at A. So we have two expressions in A. We have x squared and negative x squared, right? What do they want us to plug in? X equals what?
-11.
Negative 11. So I'm going to go ahead and do, so first things first, I'm going to rewrite the first expression. I'm going to write x squared first. Let's do that one first. We're plugging in a negative number. Since we're plugging in a negative number, what symbol needs to be around the negative 11? We need to put parentheses, okay? And then put the squared outside of the parentheses. Do we know how to evaluate an exponent with a negative number? We do, right? A negative 11 squared is just negative 11 times another negative 11. Two negatives make a what? A positive, right? 11 times 11 is a positive 121, and we're done. That's for the first one. We just did x squared right now. Now we're going to do negative x squared over here. So we're going to have a negative on the outside, right? Don't forget your parentheses to negative 11 squared. So what we're doing essentially, we're doing negative parentheses negative 11 times the parentheses negative 11. Well, we know two negative 11s gives us a positive 121. But what's still there, guys? These two give us a positive, but we still have this negative right there. Oh, crap. We still have that negative right there. So it's going to be a negative 121 as our final answer. Because we know the other two negatives make it a positive, but that third negative makes our final solution into a negative. Okay, that was A. Let me slide these down to do C. We're going to do B now. Okay, look at B. It's one expression, but they want us to do both two different z's. So we're gonna do 6z squared, right? But we're gonna do z equals 2 first. So it'll be 6 parentheses 2 squared. Now pay real close attention, class. What's being squared? The 2 or the 6? Or both? What do you think?
The 2.
The 2. So 2 squared is 2 times 2, which is just what? 4. And 6 times 4 is 24, and we're done. Now we're gonna do the z equals -2. We're doing the different z value. So it'll be 6 parentheses -2 squared. Well, a -2 times a -2, we know 2 negatives makes a +4. 6 times 4 is 24, and we're done with B.
How do you know which one to use first? Like for the first step, you use the z equals 2, but not the z equals -2.
So it doesn't matter which one you do first. This problem wants us to find, it wants us to evaluate the expression for the given values. So here we have one expression with two variables, two values. So it doesn't matter which one you do first, just as long as you get both of them done, okay? Was that your question?
Yes, thank you.
Okay. All right, let's look at C. C tells us x plus 2y plus minus z, and it gives us x, y, and z. So x plus 2y. So instead of x, I'm plugging in what number? 3. So it'll be 3 plus 2y. So 2 parentheses. What did we get for y? -5 minus z. Z is -4. We plugged in x, y, and z. So now we use Pemdas to simplify. Can someone tell me what's going to happen over here when we have negative minus a negative?
Turns into a positive.
Turn into a positive. So then we get plus 4, bring down the 2 parentheses -5, and then bring down the 3. So now we're doing PEMDAS. No parentheses, no exponents. So now we're going to go ahead and multiply. Can someone tell me what 2 times -5 is? I think that's a -10. Ah, look at the C. We have plus a negative. Plus a negative. We know what plus a negative is, right? We know when we're adding a negative number, what operation is that? Yeah. It gives us a subtracting. We're subtracting the 10. And now we add and subtract from left to right. You have 3 in your account, but we spend 10. So we owe -7 plus 4. Negatives, you owe the bank $7. So we put 4 more. So now we only owe them $3. And we're done.
I do have a question about B.
Go.
So on the second z equals -2, where did the exponent 2 come from?
Ah, look at the expression. Kayla, what do you see? Is 6z squared. The z is being squared, ma'am.
I thought that was like its own thing, or I don't know.
No. That was a great question. Like the point of lecture, Kayla, is if you're not sure why we're doing what we're doing, ask. Because when you do the homework on your own, you're able to execute on your own from the confidence from you asking anything you're confused about, okay?
Got it. Thank you.
Yeah, so feel free to give me questions. You know, it's awkward when no one asks questions. So I appreciate it. Okay, Let's look. Any questions on A, B, or C so far before we go on to D?
Yeah, I'm a tiny bit confused on why we put everything in parentheses. I know that Barry put in the comments about something about parentheses, but I was trying to read and listen to you at the same time. When you got the X, like at the first one, X negative 11 and negative 11 in parentheses up there, but I'm not sure why we all of a sudden put it in parentheses. What made us put it in parentheses?
Ah, that's a great question. So so look at the X value, Tanya. What are we plugging in? What X value is it? Negative, right? A negative 11, right? So if we go back to the very beginning, oh, why is it all warped? This is weird. Oh, I know what it is. I think it's this one, right? Okay. So when we go to the beginning, whenever we exponent a negative number, it has to be surrounded by what? Parentheses. There you go. So that's why when the told us to evaluate X equals negative 11, my instinct was to automatically include the parentheses in that expression. Now, to also talk about what Daryl was saying, he's saying whenever you're plugging in a value, it's very important to include parentheses to kind of show, hey, this was a placeholder of where the letters were at, the variables were at. Like, look, for example, at C. You know how that is X plus 2y? You see that it says X plus 2y? Well, to be able to show that it's 2 times the y, I had to put parentheses around the number I plugged in for y. To remind us, because if I didn't put that, you're just going to see this. If I didn't put 2 parentheses negative 5, you will see this 2 negative 5. And you can put a dot there, right? But you're not going to right away think multiplication. You're going to see the line and the 2 numbers. You're going to subtract instead of multiply. That's why it's very intuitive or very avoids mistakes if you actually go if you're not shy with parentheses, especially with plugging in.
Okay, thank you.
No, thank you for your question.
Professor, I think Jacob wants you to write it out as a note so he could like dictate it down, I think.
Sure thing. Let's go ahead and make a little note. So, note. When substituting, I don't even know how to spell substituting. Substituting. I'm not an English person. Don't judge me, class. And it's a video too, so I can't deny it. So when substituting values or numbers, right? Values to variables. Remember, I'm using mathematical terminology. You're college students now, so I'm not going to baby you. So when substituting values to variables, it is very important to place parentheses I don't even know that's how you spell parentheses, but I'm trying. All right. Is that what you're talking about, Jacob? The note? Like, is that a good note? Okay. Now, just while you're writing the note, you notice how I didn't put parentheses around the 3. Y'all see that? Why do y'all think that is? Why didn't I put parentheses around the 3 when X was right there? Anyone want to tell me their idea of why we didn't?
Because there's already an addition sign.
It's already an addition sign. It's by itself, right? This is adding. Nothing's gonna happen to it if we have parentheses 3 or not. You know what I mean? But with the 2 and the 5, it's gonna change how we see it. So good. Thank you. All right. We're on D, the last one, class. 7 minus x squared for x equals -4. So 7 minus x squared, x is negative, so parentheses, -4 squared. We've just plugged it in for x. Now we use Pemdas to simplify. Can someone tell me what -4 squared will be? positive 16. So then we're going to get, so that negative 4 squared here becomes positive 16, but I'm going to bring down everything else. The 7 minus stays there. Nothing has changed. Just the negative 4 squared becomes a positive 16. 7 take away 16. You have $7 in your account, but we just needed to buy Chick-fil-A and we got an extra sandwich because we're hungry. So we now owe the bank a measly $9. And we're done. Now, make sure you ask your questions because you're going to be thrown into the sharks. Next slide, you're going to have some practice problems.
Okay, I have a question.
Go
And
for it.
it's silly, but I might have missed it. So when you subtract, and then you bring up like the bank, you owe the bank. How do you know when, like instead of it just being 9, how do you know it's -9? You know
So
what
yeah, for sure. And it's gonna come with practice, right? But look at the expression we're looking at. We're looking at 7 take away 16, right? So your starting value at, now there's a lot of ways to look at it. For me, I've taught for years and I've tried holes, I tried digging, I tried a lot of concepts and nothing ever stuck with my students until I brought up money because I taught high school and college and older people know more about money. But if you want to know an actual like a representation so you can start seeing it this way, if money's not doing the trick, think about it as a number line. You know, everyone knows a number line, right? We start with 0 in the middle, right? And then we have 1, 2, 3, 4, 5, 6, 7, right? 7. And we're gonna, and then so we start off at 7 here. When we take away a number, we travel to the left side of the number line. When we subtract, we go to the left. When we add, so when we subtract, we go to the left. When we add, we go to the right? Like 7 plus 1, we move to the one right? And that's 8, right? But now, so we're subtracting 16. So let me go ahead and draw a couple more lines over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's negative 12. And then, so let's go to the left. We're subtracting 16, right? So since we're going to the left and 16 is bigger than 7, we're going to go, what's the left of 0? What numbers are to the left? Negative, right? So let's go 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is where we're going to end up at. Let's see what number that is. Negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, and negative 9. Giving this negative 9. So that's one concept you can look at adding, subtracting. So for me, the way you look at it, I want you to look at you like the first number to the left is 7. So in terms of the bank situation, that 7 means it's a positive 7. So you and I both have $7 in our bank account. When we have a plus, we add money to our account. When we subtract, we're taking money from what we have. So, and if we ever go below a 0, we now have a negative balance, which is right away I knew we spent more than what we have. So I knew it was going to be a negative 9.
Okay, I get you.
Awesome. Great question, by the way. All right, y'all ready to try out your practice problems? It's gonna be similar to these, but different numbers and letters. You guys ready? Or any other questions before I move on? Good luck. I'm gonna give you about 8 minutes on these. I'm gonna give you out 2 for each one. Remember, it's the same concept as we just did, guys, but just different letters and numbers, okay? You look at the notes, look at what we just worked out, and remember, you can always ask me for help or ask for questions. So we'll start out by writing the first one. Evaluate x squared and negative x squared for x equals negative 15. And get into it. And remember, you can ask me or Daryl for help as you work through these. Y'all can message us privately or just type in the everyone chat. Remember, guys, my philosophy is teamwork makes the dream work. So if you want to ask everyone in the classroom, a question, I'm sure others would help you out. If not me or Daryl. All right, time's about to run out, guys. All right, there should be two different answers for the first one. Will anyone let you share their two answers? What did y'all get for, let me label these. This is 1, 2, 3, and 4. So 1, we have 225. Okay, good. That's for one of the answers. What's your other answer? Up 225 and negative 225. Excellent. If you got these two answers, guys, you are correct. Would anyone need me to go ahead? If you were still working on them, go ahead and keep working on them. Would anyone like me to work out the first one?
Well, I just have a question. Did for like the first positive x2 with the negative 15, like do you have to put parentheses around it or when?
Yep, put parentheses because x is negative. Yes, that's correct. You want to put parentheses. So when you plug them in, let me show you how they should look like, okay? They should look like this. So when you're doing it, because you're going to have two expressions with the same x, right? So you're going to have parentheses negative 15 squared, and the other one's going to be negative parentheses negative 15 squared.
I get about like the negative x, but like with the positive x, I just don't understand like why or like when to put the parentheses and when not to put the parentheses.
So there's not really like let me so you're wondering, you're asking me, how do we know to go from x squared to parentheses negative 15 squared, right? You don't know when to put in. Okay, so my judgment call is if there's something outside of the letter, like a square, 2x, a 2 in front of the x, x over 4, if there's anything going around the x, parentheses to avoid it messing up. Okay, now for example, remember in the last example here, the 3, there was x was here by itself, right? And when you plug in 3, we put no parentheses around it because nothing's happening to the x. There's no, it's not being squared, it's not being multiplied by 2, nothing's happening, so there's no parentheses needed. Okay, now here, that's not the case, right? X is being what? Squared, right? So to avoid that confusion, input the parentheses to show, hey, the square was there already, but now I'm going to go ahead and put this 15 in there and I'm going to evaluate it like that. Okay, so the moment that there's something happening to that letter, you put parentheses for your safety to avoid mistakes. Okay, did that explanation make better sense of when and when not to use parentheses? Okay, I'm going to ask you, not just you, Caleb, but everyone, if we're going to put parentheses because of what we see in the expression, okay? So this does become 225. That's correct here. And then we have negative x squared. Parentheses here, yes or no? When we plug it in, do we put parentheses? Yes, right? Because we have a negative and a squared. So we need to separate what we're plugging in, right? Which gives us negative 225. So we're done here. Look at 2. When we plug in the two numbers for the y, am I going to put parentheses around the numbers? Yes or no? Look at the y. Yes, right? Because what's happening to the y? It's being what? Squared and multiplied by 5. So that's why we will use parentheses. So what did you get for the answers for 2, guys? Anyone want to share?
I got 30.
30.
No,
Okay.
correct though.
People, I see 40 and I see 80. Let's find out. So 4 squared. Remember, we had to do Pemdas, right? When we simplify expressions, right? Oh, for exponents, what's 4 squared? What's 4 times 4?
16.
16. And now what do we do with the 5 and the 16?
Multiply.
Yep. 5 times 16, I believe that is 80. Now let's do this one. Negative 4 squared. 2 negatives make a positive 16, which gives us an 80 as well. So we get the same answer for both. Do you see the difference, Maya? Why they're both positive? Because -4 times a -4, two negatives make a positive. All right, everyone see why it's 80, guys? Everyone good? Okay, let's look at 3. Evaluate x squared plus y. So when we plug in -6 for x, guys, question class, are we gonna put parentheses around the 6? Yes or no? Yes. Good. So it'll be -6 squared plus y. Am I gonna put parentheses around -3? Yes or no? Now there's no right or wrong answer.
Yes.
Now, y is
No.
by itself. So do we have to? No.
No.
No, we don't really have to. Could we though to separate it? Yeah, we could. We could, right? But if that's gonna confuse you, don't do it. Because we're gonna simplify regardless because we're adding a negative. We don't add negatives in math. When we add a negative, that's just the same thing as subtraction. So I'm just gonna rewrite that. You see what I mean? So now we simplify. What'd you get for your final answer for 3? So -6 squared, -6 times -6. What do we get?
Positive 36.
Good. And then we bring down the -3, right? And then 36 minus 3 gives us a 33. And we're done. What questions do we have so far on 1, 2, or 3? All right, let's look at 4. We have 4 minus x squared. Am I going to put parentheses around -8? Yes or no? Yes, we are. Because we're squaring a negative number. The x is being squared. -8 times -8. -8 to negative is a positive 64, but bring down everything else. 4 minus. Now looking at 4 minus 64, guys, is my answer going to be negative or positive? What number is big? It's going to be a negative answer, right? Because how much do we have in our bank account? We have how much?
4.
But we spent how much?
64.
Yeah, we got some money problem, right? So if we spend 64 when we only have 4, we're gonna owe the bank how much?
-60.
Yep. And since we owe, it's gonna be a negative value, and we're done. Any questions on the 4 practice problems we just did? So why is it not -36? Are you asking about number 3, Jacob? Why didn't we get a -36? Okay, so someone want to explain to Jacob why a -6 squared in parentheses is positive and not negative? Anyone would like to help out, Jacob?
Negative times a negative is a positive.
Because we get a -6 squared, Jacob. A -6 squared, Jacob, like Sarah said, is a -6 times another -6. And 2 negatives, sir, make a what? Like Sarah said? A positive. Do you see why it's a +6, sir? There you go. There you go. Ah, that's what we want to see. Excellent, excellent. All right, any other questions? All right. This is the last example of the day. So the only I need you to write is write this formula, the finding averages on top, find that part. One second, guys. All right, so finding averages, guys, is the last example of today. So to find averages, we're gonna sum of the numbers divided by the number of numbers. So after you write the formula for me, write the word example, write the title of this table, the monthly normal temperatures for Barrow, Alaska. And it wants us to find the average from January through April. So I want you to write these three numbers in April. So after you write the title of the table, you just right next underneath the title, you're just gonna write -13, comma, -16. Oh, -16, comma, -13, comma, 2. You know, that's you're writing these numbers out instead of drawing this table. That's like the counter here. I'm not gonna make you draw this table, but I do want to do this problem. So the graph shows some monthly normal temperatures for Barrow, Alaska. Use this graph to find the average of the temperatures for the months January through April. Monthly normal temperatures for Barrow, Alaska. So we have -13, -16, -13, and 2. So they want us to find the average, class. To find the average, they want us to add up all of these numbers. So it'll be -13 plus -16 plus -13 plus 2 over the number of numbers. How many different numbers are we adding? 1, 2, 3, 4. So 4 is going to be on the bottom. But you guys are going to notice a couple things. We've seen it before. We're adding negatives here. Adding negatives is the same thing as subtracting. So let's just rewrite it, right? So it'll be -13 minus 16 minus 13 plus 2 over 4. So now let's add and subtract on the top. 13, we owe 13 because it's -13. We spent 16, so we owe 29. We spend another 13, so we owe 42. We owe 42, but we put 2 in our account, so we get -40 over 4. Now, if someone wants to help me double check my math, can someone subtract these in their phone or calculator? Or I'll do it. I'll show you. So remember, I pushed this calculator, right? So we're going to do -13 minus 16 minus 13 plus 2. You see my calculator here. And it says -40. So then we get -40 divided by 4, which is -10. So the average temperature from those months is -10 degrees Fahrenheit. So excuse me. And we're done. That is the last example for today. I'll let y'all finish writing this one out because there was a bit of an information on it. Whew, what a brutal, we did it. That was a lot of math today. I'm sure your brain and hands feel exhausted. But for those of you that's ever tried getting in shape, working out is not meant to be easy. Good, good. Now, before I take attendance and get y'all's attendance in for today, are there any questions so far in any of the lectures? So from the stuff that we've learned right now, you guys should be able to do homework 1, 2, and 3. Those 3 assignments. And guys, get the orientation done. That should be an easy 100. That should be an easy 100 that not everyone finished. So I saw some people start it and then stop doing it. Don't stop. Get the 100 in. Because that assignment is part of your assignment grade. So might as well take advantage and get that free 100. All right, let me pull up my Canvas page. All right, make sure I'm gonna stop recording actually. That's actually a good idea.